So page 11, we're graphing quadratic inequalities. Let's break down what this title means. A quadratic is this parabola-shaped graph. And we're doing inequalities, so we're going to have these type of symbols. So we're going to be graphing these parabolas, also called quadratics, and we're going to be shading either above it or below it. That's what we're going to be doing today, okay? And here are the steps to graphing quadratic inequalities. First, we're going to make a table, and then we're going to plot the points. So we're going to plot the points. Maybe it'll look like this. And then we're going to use the symbols. So I drew a solid line. That means I probably have a greater than or less than or equal to symbol or greater than or equal to symbol. If my graph is dashed, that means, if my graph is dashed, that means I had either a less than symbol or a greater than symbol, okay? And then if it's less than, you're gonna shade below. If it's greater than, you're gonna shade above. All right, so those are the steps. And remember, guys, we want to find the vertex. Once we find the vertex, just plot the points around the vertex, and you'll have your quadratic graph. So let's do an example. Okay, so we're going to do example 6. We have y is greater than. So I already know I'm going to shade above the graph that I draw. And it's also going to be a dashed graph. It's going to be facing up. Okay? All right, so let's go ahead and start. First, let's find the vertex. So to find the vertex, we're going to use the formula negative b over 2a. So my a value is 1/2. The b value is -4. So I'm going to erase the b value, and I'll replace it with a -4. Replace the a value with a 1/2. Okay, so let's simplify this. 2 negatives is just a positive. So this is 4. And 2 times 1/2. Well, 1/2 of 2 is just 1. So the x value of my vertex is 4. Let's find the y value of my vertex. We're going to plug 4 in to this original problem. So I have 1/2 minus 4 plus 12. We're going to plug in a 4. And let's evaluate this. 4 squared is 16. Times 1/2 would be 8. You can think of it as 1/2 of 16 is 8. Minus 16 plus 12. This is -8 plus 12. This is 4. So my vertex is 4, 4. Go ahead and plot that on your graph. That's right here, 4, 4. Okay. Now let's find some more points to put on the graph. So I'm going to make a table here. I'm going to put the vertex at the center. So 4, 4 was my vertex. Let's go around it. Let's figure out 3, 2, 5, and 6. So let's put these numbers into our quadratic equation and see what the y values are. So now this time I'm going to plug in the number 3. Let's plug in a 3. So 3 squared is 9. So we're going to get 9/2 minus 12 plus 12. And that cancels out. So when I plug in a 3, my y value is 9/2. What is 9/2 as a decimal? 4.5. 4.5. So let's go ahead and graph that. The x value 3 is paired with 4.5. That's right there. And guys, since this is a quadratic graph, I know that 5 will also give me 4.5. This will also be 9/2 or 4.5. Let's plug in a 2 now. Let's plug in a 2. Okay, plugging in 2. 2 squared is 4, and 1/2 of 4 is 2. Minus 8 plus 12. 2 minus 8 is -6. Plus 12 is 6. So for 2 and 6, if we plug it in, we'll get 6's both times. So this will be 2, 6, and this will be 6, 6. So this is my quadratic equation. That's my graph. Oh, sorry, yes, it has to be dashed. We set that over here. It's going to be a dashed graph because it doesn't have an equal to sign. So let me change that to a dashed. Okay, so we're going to have a dashed graph, and our symbol is a greater than symbol. So that means we're going to shade above the graph that we just drew. So I'm going to shade above it. Now, if you want to check your work to make sure that you shaded the correct area, we can just pick a random point. So I'm just going to pick a random point. Let's say I pick this point right here. This is the point 4, 6. It's in the shaded region. So if I put 4 and 6 into my equation, it has to make sense. So let's just test it to make sure we shaded the correct side. So the y value of that point is 6, and the x value is 4. We're plugging in the point 4, 6. So 4 squared is 16. Half of 16 is 8. Minus 16 plus 12. We get 6 is greater than. 8 minus 16 is negative 8. Plus 12 is 4. 6 is greater than 4. That's true. So guys, any point that you choose in the shaded region will work. Okay, so someone just asked, will the points in the table work? They will not, because they're on a dashed line. So those are not solutions. Very good point. Okay? All right. I'm going to pause here. I want us to look at the homework. Do you guys have any questions from the homework? Yes? Okay. So let me pause here and pull up the homework. All right. So number 4 is the question. Okay. A penny dropped off the Empire State Building, which is that many feet tall. This is the equation. All right, how long would it take the penny to strike a 6-foot tall person? All right, so what did you guys do? This is the equation. Negative 16t squared plus 1,250. And the height that we want to know about is at 6 feet off the ground, correct? So for h, I'm going to put a 6. We want to know what is the time whenever the height of the penny is at 6 feet tall from the ground. Does that make sense? Okay, so let's go ahead and solve this. I'm going to use the quadratic equation, but before I do that, I need to move this 6 over to this side. So this will be negative 16t squared plus 1,250 minus 6. And there'll be 0 on this side. And then I can combine like terms. So this will be 1,244. Okay, so now I can use the quadratic formula. So it's x equals negative. Do I have a b value? No. Plus or minus the square root. I don't have a b value. Minus 4. A is negative 16. And the c value is 1,244. All over 2 times the a value is negative 16. Okay, so let's simplify this. We get plus or minus the square root of, can you guys type this into the calculator? What's negative 4 times negative 16 times 1,244? 79,616. Thank you. All over 2 square root of 2 times negative 16 is negative 32. Okay, so I know I'm going to need a positive answer, right? So I'm going to choose a negative and the negative so that I can get a positive. Okay, so guys, what is the square root of 79,616? Just type that into your calculator. 282.16. 282.16. Okay, and then divide this. We're going to get a positive answer. And that will be the x value. 8.82. Thank you. So 8.82 seconds. That is how long it would take for the penny to reach 6 feet. Okay, any more questions? Okay, another homework problem. Find two consecutive odd integers. I'm just going to pause there. If I want two odd integers, first let me allow x to be the first odd integer. And let's say, for example, an odd integer, we pick 3. The next odd integer would be 5. So whatever that is, I need to add 2 to it. So for example, if it's 7, the next one is 9. If it's 11, the next one is 13. So it follows this format. You add 2 to get to the next odd integer. So I will let x represent the first number and x plus 2 represent the second number. Okay, so now let's go to the problem. Such that the square of the first, well, this is the first one, it says to square it, added to 3 times the second, which is x plus 2, is 24. And now you just solve it. So we'll distribute. This is x squared plus 3x plus 6 equals 24. We're going to move the 24 to the other side. And combine like terms. So this will be negative 18. From here, you can either use the quadratic formula to solve for x, or you can use factoring. I'll do factoring. So two numbers that multiply to negative 18 but add to 3 are 6 and negative 3. So this will be x plus 6 and x minus 3. Those are my factors. Now we're going to solve. So this would be x is negative 6. This would be x is 3. Now notice I want 2 positive. That won't work because that one's negative. And I need it to be odd. Well, this one is positive and odd. So that means x is 3. So that means my first odd integer is 3. And if I plug in a 3 here, my next odd integer is 5. So the answer is 3 and 5. Okay, this is another question that seemed to stump a lot of people. Before we even start this, let me just give an example. Let's say I have a big rectangle and the dimensions are 5 by 6. That means the area of this big rectangle is 30. And let's say I draw another rectangle inside of it, a smaller one, and let's say the dimensions are 2 and 3. So that means the area of this one is 6. Well, if I want to find the shaded part, let me shade this in. If I want to find the shaded part, I would just do 30 minus 6 so that the area of the shaded part is 24. Okay, so we're going to use the same concept to this picture up here. The big rectangle, the area would be length times width. So that would be x plus 6 times 2x minus 1. Now, if I want to find the shaded part, I need to subtract the smaller rectangle. So the area of the smaller rectangle is x times x plus 3. And if we look at the problem, it says the area of the shaded region is 59. Now we just solve. This would be 2x squared minus x plus 12x minus 6 minus x squared minus 3x equals 59. This will be x squared. Negative x plus 12x is 11x minus 3 is 8. And then minus 6 equals 59. We'll move the 59 over, so we'll have x squared plus 8x equals negative 65. Okay, so from here you can either use the quadratic formula or you can factor. I think I will factor. Okay, so two numbers that multiply to negative 65 and add to 8 are 13 and negative 5. So those are your factors. And solve. Okay, so this is the only answer that makes sense. This doesn't make sense because I can't have negative dimension. So x value is 5. So the question asks, what are the dimensions of the outside rectangle? So if I plug in a 5 here and a 5 here, that means this side of the rectangle is 9 and this side of the rectangle is 11. So that means the bigger rectangle, the outside rectangle, is 9 feet. Oh, sorry, 9 inches by 11 inches. Okay, next homework problem is a projectile one. It says an apple is launched directly upward 64 feet per second from an 80-foot tall platform. So the equation for this apple's height at time t seconds after launch is right here. So we want to know what is the maximum height of the apple. Okay, so let me draw a picture of what this looks like. The apple goes through the air from an 80-foot tall platform. So let's say this is 80 feet. It launches and then it hits the ground. So the maximum height would be right here, which is the vertex. The vertex in this case is also the maximum. So we're going to use the vertex formula. That's negative b over 2a. So this is the a value, this is the b value. So this will be negative, because that's a part of the formula. The b value is 64, and the a value is negative 16. So if we put this into the calculator, negative 64 divided by negative 32 is 2. So that is the x value of the vertex. So I know that this point is at 2, and let's find the height, the y value. So I'm going to plug in a 2 into this equation. So that would be negative 16, 2 squared plus 64 times 2 plus 80. We're plugging this value into the equation. So 2 squared is 4. 4 times negative 64. I'm sorry. 2 squared is 4 times negative 16 is negative 64. Plus 64 times 2 is 128. And then we're going to add 80. So negative 64 plus 128 plus 80 is 144. So this is the vertex, 2 and 144. That means in 2 seconds, the height of the apple is 144 feet. So for 2A, the maximum height of the apple is 144 feet. Okay, now it wants to know how many seconds will it take for the apple to reach the ground. This is the ground right here on the x-axis. That means I need to use the quadratic formula to find the x value. So this is x equals negative b, so negative 64 plus or minus the square root. 64 squared minus 4, the a value, the c value, all over 2 times negative 16. Okay, so let's simplify this. Under the square root, 64 times 64 is 4,096. Minus all of this is a negative 4 times 16, 64. 64 times 80, 5,120, all over negative 32. This means we're going to add, so this will be negative 16 plus or minus the square root of 9,216, all over negative 32. Now, the square root of this is actually 96. So this is negative 16 plus or minus 96 over negative 32. So I'm going to choose this one. I want the numerator to be negative because the denominator is negative. That will give me a positive value. So negative 16 minus 96 is negative 160 divided by negative 32. We get 5. Okay, so that means in 5 seconds, the apple will hit the ground. Okay, so number 8 was requested. So first let's find the vertex. We're going to use the formula negative b over 2a. So my b value is negative 5, the a value is 2. So let me replace the b and the a with a negative 5 and a 2. So this will be 10 over 4. This can be simplified to 5 halves. So that is the x value of the vertex. Now we're going to plug this back into the formula to find the y value of the vertex.
Where did the 10 go?
Oh, where did the 10 come from? I'm sorry. This is just 5. So we don't simplify it. It's just 5/4. All right, so this is 5/4. I don't know why I got a 10. I multiplied it by 2 for some reason. Okay, let me clean this up so that it looks nice. Okay. So let me repeat that real quick. 2 negatives make a positive, so this is now a positive 5. 2 times 2 is 4. So the x value of my vertex is 5/4. Okay? Now, we're going to plug that into this formula, or this equation. So let me just write it down. Okay, so we're going to plug in 5/4. 5/4, 5 over 4. Okay, so 5 squared is 25. 4 squared is 16. And we're going to multiply it by this 2, so this will become 50. Or we can actually reduce this. 2 over 16, this will just become an 8. You guys see that? Okay. And then this will become negative 25 over 4 minus 12. Okay? So we need to get the same denominator. So I need to multiply this by 2 and this by 2. So that I'll have 25 over 8 minus 50 over 8 minus, let's turn this into a 8 as well. Multiply this by 8. What's 12 times 8? 96. All right, so now guys, we can keep the denominator the same, but let's combine the numerators. So I need 25 minus 50, that's negative 50. Minus 96 is negative 146. And that's a pretty big number. So guys, we can do 146 divided by 8. And that decimal is negative 18.25. So I'm just going to put negative 18.25. 5/4 as a decimal is 1.25. Okay, so let's go ahead and plot the vertex. The vertex is at 1.25, and that's the x value. The y value is at negative 18. So guys, we're gonna need to expand this graph. Okay, so we made a calculation error right here. 25 minus 50 minus 96 is negative 121. So when we put this in the calculator, we get negative 15.125. So guys, notice our graph does not go that far, so I'm going to count by twos. So I'm going to let this go negative 2, negative 4, 6, 8, 10, 12, 14, 16. So negative 1.25 and negative 15.125 is about right there. Okay, so my vertex was 1.25 and negative 15.125. That's the x value and the y value. So guys, let's go ahead and fill out our table a little bit more to find more points. Let's plug in a 0. I think that would be easy. So if I plug in a 0 to this problem, what do I get? Negative 12. So we can easily plot that. 0 with negative 12. Oh, sorry, negative 12, 2, 4, 6, 8, 10, 12. Yep, right there. And then I know that this value will also be closely negative 12. And I'm just going to graph it like that. Oh, dotted? Yes. Why is it dotted? Nope, there's no equal sign. Dotted line. Okay, also guys, this is a greater than symbol, correct? So how should I shade? Above it, so it should be like this. You should shade inside. Now guys, if you want to, you can plot more points in your table if you want more specific dots or points on your graph. I think that's fairly good. Any more questions, guys? Number 9. Yes. All right, number 9. Can you read it for me?
Y is less than negative 3x squared plus 8x plus 3.
All right, so let's find the vertex. The vertex is negative b over 2a. So this will be 8 over 6, which can be simplified to 4/3. Did you guys get that?
Yeah.
Yes? All right, so that's the x value of the vertex. Now let's plug 4/3 into the problem. So we have 3, we're plugging in 4/3. Okay, 4 squared is 16, 3 squared is 9, but there's a 3 on the outside. 3 over 9 is 1/3. So I'm going to change this to a 3. Plus 8 times 4 is 32 over 3 plus 3. Can we change this to being 3 in the denominator as well so that we get 9/3? Okay, now we'll just add across. 16 plus 32 plus 9, that's 57. And 57 divided by 3 is 19. That worked out pretty. Okay, so let's go ahead and plot the vertex. I work better with decimals. So 4/3 is the same as 1.33. It's repeated. So I'm gonna go by twos again. Actually, I'll go by twos. 2, 4, 6, 8, 10, 12, 14. Nope, that's not enough. 3, let's go by threes. 3, 6, 9, 12, 15, 18, 21. Okay, so 4/3, 1.33, and 19 is roughly right there.
Wait, so then,
You forgot the negatives.
yeah. 'Cause that-
What negative 16?
Because this time's -3. -3 is A.
Oh, is it negative? Oh, this is a negative 16. Thank you. Oh, we forgot this negative sign right here. Okay, so let's reevaluate this. Negative 16 plus 32 plus 9 is what? Which I'll get. I got 25. Yeah, I got 25. Uh-oh. 25. Okay, so 25 divided by 3 is what? 8.33 repeated. Okay, perfect. So we'll do this. 8.33. And it's repeated. So we don't have to go by threes then. Okay, so my vertex is at 1.33 and 8.33. So 1, 2, 3, 4, 5, 6, 7, 8. We're way up there. But it's negative. It'll face down. Okay, what's my y-intercept? If I plug in zeros, 3. So right there. So I know it's gonna be dashed or a dotted line, and it'll look like this. You can fill in the points. Just pick random numbers. So I know my vertex is 1.33 and 8.33. I know I have a y-intercept at 0, 3. If you want to, you can plug in like a -1. You can plug in a 3. Plug in whatever you want, and then fill out the table to get exact points. But this is the gist, and we want to be less than. So which way do I shade? Less than, that's this side. That's below the graph. So you'll be shading inside. Any questions, guys?